So now that we've defined what angles are, we're going to move into the next concept, which is measuring angles. There are going to be three different ways that we measure what angles are. First way is going to be for things that rotate a lot. These are going to be referred to as revolutions or rotations. Going back to our definition of what it is for an angle to be in standard form, one revolution would put the terminal side of the angle at exactly the same spot as the initial side. This would be considered one revolution, or more frequently, one rev. When you hear people talking about revving their engine, it's because they're giving it enough gas to make sure that the motor is completing a lot of revolutions. In the event that you are not trying to do one full revolution, what you can do is talk about, say, a half revolution, where the terminal side is directly across from the initial side. This would be considered a half revolution. Or something even smaller, like, say, putting the terminal side on the positive y-axis and doing something like this. This would be considered 1/4 of a revolution. However, somebody decided that dealing with fractions as far as revolutions were concerned was probably not going to be the best way to do things, so they said, let's take one full revolution and let's cut it up into a bunch of smaller portions. Those smaller portions are going to be referred to as degrees. So one revolution is going to be 360 degrees. Back when these concepts were being thought of, it was believed that 1 year, the amount of time that it takes for the Earth to rotate around the Sun, was exactly 360 days. So they said, we're going to let 1 degree represent the movement of the planet of 1 day around the Sun. Obviously, we know a little bit better than that nowadays, but if we were to consider some of those revolutions that we saw just a moment ago, one full revolution would then be 360 degrees. A half revolution would be half of 360 degrees. Half of 360 degrees would be 180 degrees. Because the initial side and the terminal side together form a straight line, this is very frequently referred to as a straight angle, a 180 degree angle. The 1/4 revolution would be 1/4 of 360 degrees, which is 90 degrees. This is what's referred to as a right angle. You've probably seen one of these if you've ever worked with squares, rectangles, right triangles, very common things that have right angles. Now, anytime we're dealing with a multiple of 90 degrees, the types of angles we're referring to are called quadrantal angles. Quadrantal angles would take the form of 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Anytime the terminal side is located on one of the coordinate axes, you are dealing with a quadrantal angle. Now, this again assumes that they are all positive, of course. Now, one could make the argument that given that one full revolution is 360 degrees, that 1 degree is not particularly large. One of the things that we use these sorts of measurements for is our global positioning system, or GPS for short. Now, imagine for a moment that on the surface of the Earth, so here's the Earth. Oh, that's a pretty good Earth. Imagine that you can only get accurate on your global positioning system, accurate to 1 degree based off of the central angle that you get from the middle of the Earth. In that case, your accuracy is only within 69.08 miles of your actual position. Can you imagine a GPS system that is only accurate to the nearest degree? It is for this purpose that we actually split a degree into smaller pieces. And there are 2 ways that we do it. One of the ways is referred to as degree decimal. This is where you'll simply take whatever your degree measure is and break it into a decimal portion as well. Now, with that in mind, you'll usually see a whole number of degrees, and then a tenths place, a hundredths place, and a thousandths place after that. So, unless otherwise specified, we're going to round to 3 places beyond the decimal. Now, the other way that we can split it into smaller pieces is referred to as DMS. DMS stands for degrees, minutes, and seconds. Degrees, minutes, seconds works very similarly as to what you would do in terms of hours, minutes, and seconds. For example, a typical class period for us would be about 2¼ hours. Rather than saying 2¼ hours, what we tend to say is 2 hours and 15 minutes. So 1 degree is going to be equal to 60 minutes. This is the notation that we use anytime we're referring to something in terms of minutes. And hopefully what is expected is if you have 1 minute, you can turn that 1 minute into 60 seconds. Again, works very similarly to how time works. This would be considered seconds. Now, in a little while, I'm going to go through some examples for actually making these conversions, but before we do so, oh my goodness, I just realized that 2 was degrees. Oh yeah, we're going like this. A, B. Oh my gosh, that's so much better now. We do need to talk about the other way that we can measure angles, and that is going to be the way that we see most commonly in the world of math. So the third one is referred to as radians. Radians are going to be very significant once you move into a calculus class after this. The way that a radian works is based off of a circle. If we put a point at the center of the circle and create an angle relative to the center of the circle, which we'll call theta, theta is referred to as a central angle. A radian is going to be defined as the ratio of the arc length subtended by the angle. We're going to use S to represent arc length. Arc length subtended by theta. And because it's a circle, we'll also use R to represent the radius of the circle. So the definition of a radian is to say when the arc length subtended matches the size of the radius, theta is defined to be 1 radian. 1 radian is slightly smaller than 60 degrees. However, I would like to point out that if we refer to the entire circle, so if theta is equal to 1 revolution, the arc length that we would be referring to is actually going to be the circumference of the circle. That would be 2 pi times r. So if once again we look at that ratio of s to r, this means that s over r would be equal to 2 pi radians. We can interpret this to mean that 1 full revolution is going to be equal to, in degrees, 360 degrees, and in radians, 2 pi radians. Now, if I don't write a symbol after the measure of my angle, you may assume that I am talking about radians. So one quick note here. Usually, a radian measure is given as a multiple of pi. Typically a fraction times pi, but we'll see that once we actually start working through some examples. Now, this also means that if I wanted to convert between degrees and radians, we have a method to do so. Now, I did mention up here just a moment ago that 360 degrees also represents 2 pi. If I were to take a common factor and divide it on both sides, I could also say that pi radians is equal to 180 degrees. Both of those measures are referring to the half revolution. So if I am given something that is measured in degrees, and I'm interested in converting it to radians, I can do so by multiplying by pi radians divided by 180 degrees. This will give me an angle theta measured in terms of radians. Now, if I'm given an angle that is measured in radians and I'm interested in converting to degrees, I would do the opposite. In chemistry, they call this stoichiometry. In physics, they call this dimensional analysis. And here in math, we refer to it as unit analysis. Take whatever you are converting from, put it on the bottom. Take what you're converting to, put it on top. This works anytime you're dealing with something that's not already a fraction. Now we'll take a look at some example problems in just a moment.